everybody, and welcome to this official Architecture Technology podcast. My name is Robert, and you are watching Chapter 14. Now, anyways, I just wanted to get started on today's video.
What are you doing?
Wait, what do you mean?
This isn't your podcast.
Oh, excuse me. I'm in the wrong podcast. Hang on a minute.
Anyways. Hi guys, today we're going to be discussing Chapter 10, Masonry Wall Construction.
Where the heck is my video? I could have sworn I thought it was
Hi guys, my name is Jazmine, and today I will be discussing the different masonry walls. So the world's most enduring buildings are constructed of masonry. Their thick monolithic walls provide strength, durability, and thermal regulation. However, contemporary construction combines masonry with more modern materials and technological advancements to create lighter and thinner walls. So there are different types of these walls. The first one I'm going to talk about is composite masonry walls. So these are solid walls that consist of multiple widths or layers bonded together to function as a unified structure. So these walls use different masonry materials in various sections to optimize appearance, durability, and cost efficiency. High quality materials like terracotta, stone, or facing brick form the outer layer, and more practical materials like building brick or hollow clay tile are used on the inside layer. So historically the widths were bonded with header units and metal anchors, but modern construction favors steel ties and reinforcing. Every masonry wall is porous to some degree. Therefore, masonry cavity walls have a hollow space between the outer width and the backup width to manage moisture and insulation. Water that penetrates the outer layer drains down the cavity and exits through weepholes at the base. So how does this work? The masonry ties connect the veneer to the backup, and flashings catch and redirect water out of the wall. Damp-proofing prevents water from reaching the interior, and insulation such as foam or material fiber improve energy efficiency. Load-bearing cavity walls is one type of cavity wall. So this is when the backup width supports the structure. And then there are also non-bearing cavity walls, and this is when the backup width provides lateral stability. So load-bearing masonry walls may be built with or without reinforcing. So what's the difference? Well, unreinforced masonry walls were used to construct multi-story buildings. However, they are weaker and susceptible to lateral forces from earthquakes, strong winds, or underground pressure. And that is why construction favors reinforced masonry walls. So most contemporary masonry load-bearing walls are reinforced with steel bars or other materials that enhance tensile strength and ductility. Reinforcement improves the wall's resistance to lateral forces and allows for thinner walls, reducing material costs, labor efforts, and the amount of floor space occupied by structural walls. And then finally, there's post-tension masonry walls. So these are made with steel rods or tendons that are embedded within the masonry walls in vertical cores or between widths. These rods are then anchored to the foundation at the bottom of the wall and are tensioned, compressing the masonry, increasing its resistance to the forces that could cause damage.
2, 1. Hello guys, today I'm going to be talking about detailing masonry walls. So one aspect that we have to look at when we're learning about masonry walls is the cavity drainage and the flashings. So the traditional recommended separation between whites of a cavity wall is no less than 2 inches. For those who know the metric system, it's 50 millimeters. So this provides enough space for the masons to keep the cavity free of mortar obstructions while the wall is being built. Where insulation is inserted into the cavity, the remaining clear space within the cavity is maintained at a depth of at least 1 inch, 25 millimeters. Or if alternative provisions are made to ensure adequate cavity drainage, such as insertion of a continuous drainage mat behind the veneer, the depth of the clear space may be reduced further. So weep holes at the cavity bottom should be spaced not more than 24 inches, 600 millimeters, horizontally in brick, and 32 inches, 800 millimeters in concrete masonry. Whips should lie immediately on top of the flashing in the wall to keep the bottom of the cavity as dry as possible. These weaves are formed by leaving open head joints between units that make the weave the full width of the joint and at least 2 inches, 50 millimeters tall. To prevent insects from taking up residence within the cavity, by this I mean insects living in the cavity, stainless steel, wool, or plastic or metal screens are inserted into the open joints. So weaves may also be formed with plastic tubes laid in the head joints as they are mortared, and masonry flashings are used 2 ways. The first one is the external flashings to prevent moisture from penetrating into the wall at vulnerable exposed surfaces. The second one is internal flashings. By this, I mean that they catch water that has entered the wall and drain it through weep holes back to the exterior. Another term that it's very important for you to remember is metal cupping. So metal cupping at the top of a masonry parapet is one example of an external flashing. It acts to prevent water from entering the wall at the highly exposed location, and it also helps with the intersection of a flat roof and a wall parapet, which is usually constructed in 2 overlapping parts: a base flashing that is part of the roof membrane and an external metal counter flashing. Okay, I'm also going to be talking about special problems of masonry construction. So we have expansion and contraction. Masonry walls expand and contract slightly in response to changes in both the temperature and the moisture content. So the thermal movement is relatively easy to quantify. Moisture movement is more difficult. New clay masonry units tend to absorb water and expand gradually under normal atmospheric conditions. New concrete masonry units usually shrink somewhat as they give up excess water following manufacture. Expansion and shrinkage in masonry materials are small compared to the moisture movement in wood or the thermal movement in plastics or aluminum. Still, these changes must be taken into consideration in the design of a building by providing joints of the appropriate types to prevent excessive forces that could crack or spoil the masonry. So there are 3 different kinds of movement joints that are used in masonry, right? So we have the expansion joints, which these are breaks in the material that can close or open to accommodate expansion and contraction due to changes in moisture content, temperature, structural movements, or other effects. Control joints are intentionally created planes of weakness that can open to accommodate shrinkage in masonry surfaces, and it's usually during initial curing. So isolation joints are another type, and these are placed at junctions between masonry and other materials. This can also be placed between the new masonry and the old masonry. So the joint reinforcing must be interrupted at movement joints so that it doesn't restrain the opening or closing of the joint. To prevent out-of-plane displacements of the wall, various kinds of vertically interlocking details may be used. Most movement joints in masonry walls are closed with flexible sealants to prevent air and water from passing through.
You know, I could have sworn I thought I saw my podcast here somewhere. Hey, Mr. Morales, I was wondering, have you by any chance seen my podcast anywhere?
What? Hello, my name is Cristian, and I'm going to be talking about the movement joints in the buildings. And buildings and the materials are constantly in motion. Many of these motions are cyclical and never ending. Some are caused by temperature changes, and all materials shrink as they grow cooler and expand as they become warmer. Most porous materials grow larger when wetted by water or humid air and smaller when they dry out, also at rates that vary from one material to another. These cyclical motions caused by temperatures and moisture can occur on a seasonal basis, so it's warm and moist in the summer and cold and dry in the winter. Some motions are a one-time thing. For example, concrete and stucco shrink as they cure and dry out, whereas gypsum plaster expands upon curing. Clay bricks expand slightly over time as they absorb atmospheric moisture. Concrete columns shorten slightly, and concrete beams and slabs sag a bit due to plastic creep of the material during the early years of the building's life, and later on they will then stabilize. Most of these motions are small in magnitude, but they occur in buildings of every size and every material. If they are ignored in design and construction, they can cause aesthetically unattractive damage to finishes or more serious distortions and failures of building components. We accommodate these inevitable movements in buildings in two ways. In some cases, we strengthen the material to enable it to resist the stress that will be caused by an anticipated movement, as we do in adding shrinkage, temperature steel to a concrete slab. But in most cases, however, we install movement joints in the fabric of the building that are designed to allow the movements to occur without damage. We locate these joints in places where we anticipate maximum potential distress from expected movements. And we place them at irregular intervals in large surfaces and assemblies to relieve cumulative stresses. A building that is not provided with suitable movement joints will make its own joints by cracking and spalling at points of maximum stress, creating a situation that is unsightly at best and sometimes dangerous or catastrophic. And these are the types of building joints and movement joints. There are many types of movement joints and their subcategories. First, there is a non-movement joint that includes most types of joints that are used to connect pieces of material in a building. Joints such as the nailed connections in the wooden frame of a house, mortar joints between masonry units, welded and bolted connections in a steel frame, and joints between pours of concrete. Non-movement joints are pretty self-explanatory, but movement joints are the opposite. So the first and simplest movement joint are working joints, which are designed into various building materials and are created in the normal process of assembling a building. An excellent example is the ordinary shingled roof, which is made up of small units of material that are applied in an overlapping pattern. There are also structure/enclosure joints that separate structural from non-structural elements so that they will act independently. A simple example is the deflection track sometimes provided at the top of a metal framed interior partition to allow the structure above to deflect without imparting loads into the non-bearing wall framing. Next one is the isolation joints, and they separate materials or assemblies that must be able to move independently without interfering with one another. For example, when an existing building is altered or enlarged, isolation joints may be inserted between old and new construction to allow normal, one-time movements to take place in the new materials without disturbing the original construction. There's also control joints that are deliberately created lines of weaknesses along which cracking will occur as a surface of brittle material shrinks, relieving the stresses that would otherwise cause uncontrolled or random cracking. Expansion joints are open seams that can close and open to allow expansion and contraction to occur in adjacent areas of material. Expansion joints in brick walls permit the bricks to expand slightly under moist conditions. Building separation joints divide a large or geometrically complex building mass into smaller, discrete structures that can move independently of one another. There's also settlement joints. Settlement joints are designed to avoid distress caused by different rates of anticipated foundation settlement between different portions of a building, as between a high-rise tower and a connected low-rising wing, or between portions of a building that bear on different soils or have different types of foundations. And the last one would be seismic separation joints, and they're used to divide a geometrically complex building into smaller units that can move independently of one another during an earthquake.
Hi guys, it's Jazmine again. So what we've done is prepared a little PowerPoint for you guys, kind of recapping everything that this chapter talks about. So once again, I wanted to present to you guys masonry wall construction. So, first, we need to define what a masonry wall is. Now, there are different types, but the first one is a masonry load bearing wall. So, these walls are constructed of brick, stone, or concrete masonry. They serve as structural support and enclosure. They're economically competitive with separate systems, and the working stresses are lower than ultimate strengths for safety reasons. There are also reinforced and unreinforced masonry walls. So, unreinforced masonry walls were historically used in multi story buildings, and you were able to build up to 16 stories. Although they are weaker and vulnerable to lateral forces such as earthquakes and wind, modern codes generally prohibit their use in new construction except when used for low risk applications. Reinforced masonry walls are what most load bearing masonry today is. These allow for thinner walls, leading to savings in materials and labor. Next up is post tension masonry walls. So, the definition of this is walls that utilize high strength steel, rods, or tendons tensioned after construction for added strength. To construct these, steel rods or tendons are anchored to the foundation and embedded in the wall. Mortar is cured and the rods are tensioned, providing vertical compressive pre-stress. The benefits of using this is increased resistance to lateral forces from wind or seismic activity. These allow for thinner walls with fewer grouted cores, saving material and labor. Next up is masonry ties and joint reinforcing. So, the purpose of these is to enhance stability and strength between different masonry elements. And there are different types of ties. So, the first one is corrugated ties. These are used for low rise veneer anchoring. C ties are stiffer, providing better support. Adjustable ties allow adjustments for irregular course heights. Ladder and truss ties combine horizontal reinforcement with masonry ties. And finally, seismic tab ties ensure strong connections in earthquake-prone areas. There are also different types of movement joints. So, movement joints accommodate expansion, contraction, settlement, and seismic shifts. So, the different types include volume change joints, settlement joints, and seismic joints. There are a few design considerations that need to be taken into account. So, one of them is maintaining alignment with interlocking units, gaskets, or dowels. Joints must prevent passage of heat, air, water, sound, and fire. Next up is something called efflorescence in masonry. So, this is when white crystalline deposits on masonry surfaces. This is caused by water soluble salts that migrate through masonry and evaporate. So, there are a few ways to prevent this. You could use masonry units tested for salt content, use clean mortar ingredients, minimize water infiltration, and or you can remove this with brush and water. Masonry walls can also experience mortar joint deterioration. So, this is the weakest part of masonry walls. It's caused by water accumulation, freeze thaw cycles, and poor mortar application. To prevent this, you could use weather resistant mortar, ensure well compacted joints, or repair it by repointing, which is when you remove and replace deteriorated mortar. We must also know about moisture resistance in masonry. So, masonry is porous and can absorb water, but there are a few waterproofing strategies. These include the cavity wall construction versus solid walls, proper joint tooling and mortar selection, flashings and weep holes, protective coating such as stucco, breathable paints or water repellents, and below grade waterproofing, which includes parging and waterproofing coatings. So that's pretty much it, everyone. These are just a few of the main points that we covered. And yeah, we will see you guys for the next podcast.
find my podcast anywhere.
Okay, the next thing I'm going to be talking about is thermal insulation. So a solid masonry wall is a poor insulation.
Hi guys, my name is Jazmine, and today I will be talking about the different types of masonry walls. So the world's most enduring buildings are constructed of masonry. They're thick my god, bro.